Hello there, and welcome. Tonight, we are not staying in the present. We are not even staying within the span of human history. Tonight, we step out of our own time into the deep memory of the Earth, a memory that stretches not in centuries or millennia, but in hundreds of millions of years. Imagine closing your eyes and breathing in, and when you open them, the sky above you is no longer blue, the land beneath your feet no longer familiar, the air itself hostile to your lungs. This is not our world anymore. This is the Earth of 450 million years ago. The Earth has endured 5 episodes where life itself nearly collapsed. Moments when the abundance we take for granted today was erased, leaving only fragments of survivors. The Natural History Museum in London defines these events, mass extinctions, as moments when at least 75% of species vanish in a geologically short window. And short, in the language of the Earth, means anything from a heartbeat to 2 million years. For us, unimaginable. For the planet, just a sigh. What does it mean when 3 out of 4 species disappear? What happens when food webs unravel, when ecosystems dissolve from their roots? Who falls first, the towering predators or the invisible creatures at the foundation of life? These are the questions that mass extinctions whisper, and the first whisper we hear comes from the Ordovician period. The Ordovician, the air is thick with carbon dioxide. Step into it without protection and your lungs collapse. The seas are everything, shallow oceans spread across continents, shimmering with sunlight that feeds algae. Trilobites crawl across the seafloor like armored beetles of the deep past. Crinoids stretch upward, their feather-like arms catching currents. On land, life is only beginning. Simple plants crawl across wet soil. Small arthropods scuttle cautiously near the shore. But there are no trees, no buzzing insects, no birds. The sky is silent. The world is waiting for voices it has not yet invented. We think of forests as places full of green crowns of leaves. But in this world, the greatest forests are underwater. Shallow seas are crowded oases. Where light reaches, algae bloom, invertebrates flourish, entire communities thrive. But most of the oceans remain empty blue deserts, lifeless plains stretching in darkness. To swim across them is to wander across an endless wasteland, broken only by pockets of abundance along the coasts. The continents move quietly, yet their quiet reshapes the world. A southern landmass drifts closer to the pole. Ice begins to spread, white fingers creeping across the planet. Glaciers grow, seas retreat. For us, this would feel like a slow-motion catastrophe. For the Earth, it is simply tectonics, slower than fingernails growing, continents inching across the globe with patience older than mountains. But this patience carries a hidden cost. As seas retreat, shallow waters vanish. Sunlight no longer reaches reefs. Algae decline. Less algae means less oxygen. Less oxygen means less life. The collapse begins at the base, at the smallest scale, and ripples upward. Trilobites searching for food find only bare rock. Crinoids waving in the current reach into emptiness. Entire communities starve in silence. It is not one night of terror, not a single disaster. It is a chain reaction stretched across thousands of years. Geology pressing biology into a corner. And when the foundation falls, the tower above it cannot stand. If the oceans were a city, the shallow coasts were its busy neighborhoods, lit and thriving. And then, as if overnight, the sea pulled the sidewalks away. Imagine walking to your favorite street only to find the ground missing, the houses gone, the lights extinguished. Life has nowhere left to gather. From orbit, the Earth looks scarred. White ice spreads across the pole. Shorelines redraw themselves. The outlines of continents change, erasing coastlines where life once clustered. From this distance, the Earth looks quiet, elegant, serene. But close to the surface, that serenity is death. On the seafloor, a trilobite stirs, crawling across a familiar route. It does not know that the reef it depended on is gone. It does not understand that the water above it is thinner in oxygen, that algae have vanished. It simply crawls, instinctively repeating a path that no longer sustains it. One day, it will stop, and no descendant will continue the line. In the fossil record, its story ends. By the close of the Ordovician, 85% of species are gone. The first great mass extinction. Not the last, not even the worst, but enough to change the direction of life forever. Entire lineages vanish, food webs collapse, and the survivors, scattered and few, inherit a planet stripped of voices. It wasn't only the cold, it was the cascade. Ice lowering the seas erasing the light starving the base, and the collapse rising upward, every link breaking in turn. For us, the story feels inevitable when told in retrospect. For them, it was simply the silence of hunger, spreading slowly, inescapably, and still life endured. It endured in the small, the quiet, the overlooked. Life retreated into corners, into forms we would find unimpressive, and yet those unimpressive survivors carried the torch forward. From them, the Earth rebuilt. From them, the story continued. It is tempting to imagine an extinction as a sharp cut, a moment when the curtain falls. But the Ordovician extinction is more like a long dimming of the lights, each year a little darker, each decade a little emptier, until one day the theatre is silent and no one remains to applaud. We stand here in imagination and try to understand what 85% truly means. Not 85% of a single forest, not of a single region, 85% of all life on Earth. Creatures that had thrived for tens of millions of years disappear forever. And yet, for the Earth, this is not tragedy, this is transition. The Natural History Museum reminds us, extinction is not an accident in the history of life, but part of the process itself. Without extinction, no new species can arise. Extinction clears the stage so that new actors can step forward. It is the price of change, written into the logic of evolution. And so, the Ordovician ends. The seas are emptier, the reefs are gone, the trilobites are fewer, and the survivors wait for what comes next. But Earth does not stand still. 100 million years pass. The scars of the Ordovician heal. Forests spread, green where once there was only stone. Fish evolve new shapes, new strategies. Some dream of leaving the water entirely. And in that dream lies both promise and danger. For in the Devonian, the second great extinction waits. The Ordovician fades, and with it the first of Earth's great extinctions. But life does not stop. It rebuilds, slowly, cautiously, in the silence left behind. The oceans, once stripped bare, begin to shimmer again with new players. Time passes in measures almost too vast to imagine. Tens of millions of years unfold, and the scars of the past are buried under new beginnings. Now the calendar of deep time opens to the Devonian, the age of fishes. The world is alive again, but alive in ways that feel unfamiliar to us. This is not a return to what was lost. It is something new, Step into this ocean, and it is no longer the world of trilobites alone. Fish dominate now in forms both strange and astonishing. Jawless fish drift like armored ghosts, their bodies encased in bony plates. Others, newly evolved with jaws, surge forward with power. Their teeth glint in the filtered light, tools designed for hunting in ways no creature had mastered before. The Devonian seas are experiments in motion. Sharks appear, sleek shadows cutting through currents. Giant armored fish, known as placoderms, patrol the waters like living fortresses, some reaching lengths of 6 meters, their jaws powerful enough to sever prey with a single bite. These oceans are crowded, colorful, chaotic. Coral reefs bloom into vast underwater metropolises, more complex than anything Earth has ever seen before. They rival modern reefs in size and beauty, living cities of stone and flesh where thousands of species find a place to thrive. Algae cover the rocks, sponges filter the water, corals build towers, fish weave through crevices, predators stalk the shadows. It's a world that feels finally busy. On land, the silence begins to break. For the first time, true forests rise. Plants that once clung low to the ground now stretch upward, their stems hardening into woody trunks. The air fills with spores and the scent of resin. Simple ferns spread into carpets, while taller trees of primitive kinds build the first green canopies. From orbit, Earth no longer looks barren at its edges. Dark streaks of forest spread along rivers and deltas, announcing the arrival of landscapes we might recognize. And following the plants come the animals. Small arthropods creep among stems. Millipedes, scorpions, and the first insects explore these strange new habitats. They breathe air that earlier creatures could not. The sky, once silent, now holds the faint tremble of wings. Life is climbing onto land, and with it, a new frontier opens. Fish, too, begin to test the edge. In shallow, swampy waters, lobe-finned fish evolve strong, muscular fins. Fins that can do more than swim. They can push, they can crawl, they can bear weight. Some of these pioneers haul themselves onto mud flats, gulping air from primitive lungs. They are awkward, clumsy, but determined. Each step, however small, is a rehearsal for the age of amphibians, and eventually the reign of creatures that will one day dominate the land. This is a world of promise, but promise is never without danger. Complexity comes at a cost. Food webs are more intricate, ecosystems more delicate, and the Devonian earth hides instability beneath its thriving surface. The first warning signs are written in stone. Black shale, layers rich in organic matter, tell us of ancient seas suddenly starved of oxygen. Vast regions of the ocean slip into anoxic silence. Life can no longer breathe there. Reefs suffocate. Fish die. Currents falter. It is not everywhere at once, but like a spreading stain, zones of death move across the globe. What causes this? Scientists point to the forests themselves, plants pulling carbon dioxide from the air, roots breaking into rock, weathering minerals, releasing nutrients into rivers. These nutrients pour into seas, feeding algae in vast blooms. Algae grow, die, and sink, consuming oxygen as they decay. The result is poisoned water, a chain reaction set in motion by the very success of plants on land. Imagine a reef, brilliant and busy one year and choked in darkness the next. Fish suffocate in masses, their gills straining in vain. Corals collapse. The architecture of the reef crumbles. Creatures that depended on its shelter are left exposed, drifting into extinction. It is not one disaster, but many. a series of pulses across millions of years. Sometimes the oceans recover briefly. Life surges again, only to be cut down once more. Each pulse takes more than the last until the resilience of ecosystems is gone. Placoderms, the great armored fish of the Devonian, once masters of the seas, vanish forever. Coral reefs that had grown into vast underwater cities collapse and do not return for hundreds of millions of years. Trilobites, still survivors since the Cambrian, lose many of their forms, never to recover their former glory. Whole lineages disappear, erased from the story. By the end, the Devonian has taken 75% of marine species. Another of the planet's great extinctions. It is slower than the Ordovician, stretched across intervals, a drawn-out struggle rather than a single blow. But its impact is no less devastating. Stand on the shore of this world and watch as forests rise, but oceans fall silent. It is a paradox. On land, green triumphs. In the seas, life collapses. Two Earths exist at once, one thriving, one dying. And what of the pioneers? Those lobe-finned fish daring to leave the water. They survive. They stumble into the future. In the wreckage of the Devonian seas, these creatures carry the flame forward. From them will come amphibians, reptiles, mammals, and ultimately us. Without the Devonian extinction, perhaps the path to land would have been slower, delayed, or altogether different. Our own story is written in this collapse. The fossil record does not tell stories with intention, but when we look back we cannot help but see patterns. Extinction as tragedy, extinction as opportunity. The Devonian extinction clears the seas of giants, but leaves room for survivors to innovate, to move into spaces left empty. Evolution is cruel, but it is never idle. The Natural History Museum reminds us again, mass extinctions are not only ends, they are thresholds. They mark the end of one chapter and the beginning of another. For every silence they impose, a new voice waits to speak. By the close of the Devonian, Earth is quieter. The reefs are gone, the armored fish extinct. The oceans hold fewer shapes, fewer colors. But on the riversides, in the shadows of primitive trees, small creatures climb, breathe, and take tentative steps into the air. They are fragile, awkward, vulnerable, but they will inherit what the seas have lost. Life is not fair, and the earth does not promise balance, but it does promise change. Always change. And through that change, the Devonian gives way to what comes next. The Carboniferous will follow, a world of coal swamps, of giant insects, of forests spreading like green fire across the continents. But before we reach it, the silence of the Devonian teaches us a truth. Growth can carry danger. Abundance can plant the seeds of collapse, and extinction once more proves itself not an exception, but a rule. The Devonian whispers, and we listen. Life endures, but it never endures unchanged. The Devonian passes into memory, forests rise higher, insects spread their wings wider, and amphibians grow bold along the swamps. Evolution is relentless. It shapes, refines, and tries again. The world has not yet reached its greatest drama, but it is preparing. And as the ages roll forward into the late Paleozoic, a new era takes shape. This is the Permian, the final act before the curtain falls on the Paleozoic stage. And what an act it will be. The continents once scattered are now gathering together. Tectonic plates push land masses into collision. stitching the supercontinent Pangaea into being. A single, massive world island stretching from pole to pole, wrapped in coastlines thousands of kilometers long. Surrounding it, the Panthalasic Ocean covers most of the planet, a seemingly endless expanse of blue. To the east, a smaller sea forms, the Tethys, warm and tropical, promising new ecosystems. From space, Earth looks almost alien. One vast land, one vast ocean. Extremes of climate define this arrangement. The interior of Pangaea is arid, deserts stretching further than any before, but along coasts and rivers, lush forests bloom. Swamps hold amphibians and reptiles in teeming variety. The climate is unstable, dry one season, flooded the next. Yet within this instability, life thrives. Forests are thick with strange giants. Glossopteris trees dominate the southern continents, their fern-like leaves carpeting the ground in green. Insects, freed by oxygen-rich air, grow to astonishing sizes. Dragonflies with wings the span of hawks patrol the skies. Millipedes 2 meters long crawl across the forest floor. Amphibians, once confined to swamps, now diversify into formidable predators, some the size of crocodiles. But something even more significant is happening. In the shadows of the forests and deserts, a new kind of animal is rising. The synapsids, creatures that are neither reptiles nor mammals, but precursors to both. Dimetrodon, with its great sail-backed body, stalks the Permian landscape. Gorgonopsids, with saber-like teeth, rule as apex predators. These are not yet mammals, but they carry within them the seeds of what mammals will become. Warm-bloodedness, complex jaws, differentiated teeth, all begin here. Smithsonian researchers note that many of these synapsids were already experimenting with traits that would one day define our lineage. The Permian seas are no less vibrant. Coral reefs regrow after the Devonian collapse, rebuilt by sponges and algae. Brachiopods, mollusks, and ammonoids crowd the ocean floor. Sharks and bony fish prowl above. Trilobites, though diminished, still cling to survival in scattered forms. This is not yet a dying world. On the contrary, it is flourishing, diverse, ambitious. But deep within, forces are stirring. Forces that will turn this abundance into silence. It begins quietly. Volcanism increases, especially in the region that will one day be Siberia. At first, it is episodic. Lava flows, ash clouds, gases filtering into the air. Life adapts, life continues, but the eruptions grow, feeding upon themselves. What geologists call the Siberian traps, one of the largest volcanic events in Earth's history, begins to unfold. Imagine lava not as a river, but as an ocean. For hundreds of thousands of years, basalt floods the land. Layer upon layer builds a plateau thousands of meters thick, covering millions of square kilometers. Smithsonian geologists remind us that the Siberian traps may have released enough lava to bury the entire United States several kilometers deep. And with the lava comes something even more dangerous: gases. Carbon dioxide floods the atmosphere, methane seeps from destabilized seafloor deposits, sulfur dioxide clouds the sky. At first, temperatures fluctuate, cooling under sulfuric aerosols, then warming under greenhouse gases. Seasons become unstable, rain grows acidic, forests sicken. The chemistry of air and sea changes in ways life cannot ignore. Oceans absorb the excess carbon, and with it they acidify. Coral reefs struggle, shells dissolve, plankton falter, oxygen levels drop. Vast, dead zones spread through shallow seas. Smithsonian paleontologists studying fossilized sediments show that many Permian oceans turned euxinic, rich in hydrogen sulfide, toxic to most life. Imagine swimming into a sea that smells of rotten eggs, where poison drifts upward from the depths. Few creatures survive long in such waters. On land, climate spirals into extremes. The interior of Pangaea, already dry, becomes scorched. Droughts intensify. Rivers vanish. Soils crack. Where once Glossopteris forests grew, barren wastelands remain. Fires rage uncontrollably. Atmospheric oxygen, once high, begins to collapse. Insects that had grown to giant size shrink. Their metabolisms no longer supported, and then the extinctions begin in earnest. Marine ecosystems, the richest of the Permian world, are the first to crumble. Reef builders die out almost entirely. Trilobites, survivors since the Cambrian, vanish at last. Brachiopods collapse, their dominance ended. Ammonoids dwindle to near extinction. Fish, sharks, and marine reptiles suffer catastrophic losses. In total, 95% of marine species are wiped out. 95%. The oceans are silenced. On land, 70% of species vanish. Synapsids, once rulers, are cut down to a handful of lineages. The mighty Gorgonopsids, apex predators of their time, disappear forever. Dimetrodon and its kin are already gone, replaced by new synapsids, but even these new arrivals suffer terribly. Amphibians collapse in diversity. Insects, resilient across all other mass extinctions, lose entire orders. Forests burn, shrink, and in many regions, vanish. This is the Great Dying, the worst extinction event in the history of life. Nothing before or since has equaled its devastation. For paleontologists, the scale is almost incomprehensible. Entire ecosystems erased. Whole evolutionary experiments ended. The fossil record, rich and varied below the Permian boundary, becomes sparse, a record of absence rather than presence. Smithsonian researchers describe it as if the biosphere itself reset, life forced to rebuild from scraps. And yet, as in all stories of extinction, there are survivors. Small burrowing synapsids endure, their habits protecting them from surface extremes. Certain reptile groups cling on, soon to diversify into the archosaurs, ancestors of crocodiles, pterosaurs, and dinosaurs. Tiny marine organisms manage to adapt, carrying the base of the food chain forward. Evolution finds a way, though at a terrible cost. The Great Dying is not a single moment, but a drawn-out catastrophe. Many estimates suggest it unfolded across 60,000 years, though some pulses of death may have been faster. 60,000 years may seem long, but in geologic time, it is a heartbeat. In that brief span, Earth lost nearly everything it had built over hundreds of millions of years, and the causes are still debated. The Siberian traps remain the leading suspect, their vast emissions triggering runaway greenhouse warming, ocean acidification, and toxic euxenia. Some scientists argue for an additional role of asteroid impacts, though evidence is less clear than for the later event that ended the dinosaurs. Others point to coal deposits ignited by lava, releasing clouds of carbon and methane. It may have been all of these, a cascade of disasters feeding one another, until the biosphere could not withstand the strain. What does it feel like, this silence? Imagine standing in a Permian forest as the air grows thin. The chirp of insects fades. The croak of amphibians is gone. Even the wind seems quieter, stripped of leaves. Along the shore, reefs crumble and waves break against lifeless rock. The diversity of sounds, the music of life, dwindles to nothing. It is a world hushed not by peace, but by absence. And yet, extinction is not the end of the story. It is the prologue to renewal. Out of the survivors will come new dominions. Archosaurs will rise, giving birth to the dinosaurs. Synapsids will shrink into shrew-like creatures, only to re-emerge millions of years later as mammals. The oceans, barren now, will refill with new forms, corals of modern design, mollusks, new fish. The great dying clears the canvas with brutal efficiency, but life will paint upon it again. The Natural History Museum in London tells us every extinction is both an ending and a beginning. Without the Permian catastrophe, there would have been no dinosaurs, no mammals, no us. We are not separate from this story, we are born from it. The Permian whispers its truth. Abundance is fragile, stability is temporary, and life, for all its resilience, is never guaranteed. But it also reminds us that survival is possible, even in the bleakest of chapters. The Great Dying is a scar on Earth's memory, etched into rocks, into fossils, into the chemistry of sediments. But scars are not only reminders of pain, they are reminders of healing too. What comes after may be different, diminished at first, but it will grow. And so the Paleozoic ends, not with a quiet conclusion, but with fire, poison, and silence. A world emptied, a stage cleared, waiting for the next act. What follows is the Mesozoic, the age of reptiles. Dinosaurs will dominate, oceans will teem again, forests will spread. But always, in the deep background, the Great Dying lingers, a reminder that even the mightiest empires of life can fall. And that change, however cruel, is the only constant. The silence of the Permian lingers. For millions of years, the scars remain. Forests thin, oceans murky. Life is not gone, but it is humbled. The Great Dying was not just an extinction, it was a near erasure. Yet from that erasure, the story continues. The Triassic begins in shadow. Landscapes are barren, soils poor. The air, heavy with carbon, is warmer than before. Oceans, stripped of oxygen, take time to heal. It is as if the planet itself is catching its breath after the trauma. Smithsonian paleontologists note that recovery after the Permian was the slowest of all mass extinctions, 10 million years or more before ecosystems began to resemble their former richness. But slowly, haltingly, life stirs. Small plants return first. Ferns, cycads, ginkgos, they spread across the land, stabilizing soils, drawing down carbon, weaving green back into gray. Insects reappear, though diminished. Beetles, resilient across ages, crawl into the new forests. Dragonflies take wing again, though smaller now, their giant ancestors left behind. And with plants come animals. Amphibians, once abundant, are fewer but still cling to rivers and swamps. Synapsids, those mammal ancestors who survived the Great Dying, remain, but they are no longer dominant. Once rulers of the Permian, they are now survivors, cautious and reduced. Small cynodonts, creatures with whiskers and sharp teeth, skitter through underbrush, feeding on insects. They are shadows of what will one day become mammals. In the oceans, life also crawls back. Mollusks return in modest diversity. Ammonoids, survivors of near extinction, rebound explosively, filling niches left empty. Tiny plankton begin to rebuild the base of the food chain. Reefs reassemble, this time with new architects. Scleractinian corals, the same lineage that still builds reefs today, Smithsonian geologists often point to the Triassic seas as the birthplace of the modern ocean, where many lineages familiar to us now first took root. But on land, a new power is rising. Reptiles, freed by the vacuum left by the Great Dying, they diversify rapidly. Archosaurs, ruling reptiles, emerge in forms strange and varied. Some evolve armored plates and heavy bodies, ancestors of crocodiles. Others grow light, agile, with long hind limbs built for running. These are the early precursors of the dinosaurs. At first, they are small and unremarkable. In the Middle Triassic, most dinosaurs are no bigger than dogs or deer. They live in the margins, overshadowed by larger archosaurs like Rauisuchians, immense predators with crocodile-like jaws and towering legs. But dinosaurs possess something different. Their hips and limbs align beneath the body, allowing efficient, upright movement. They are lighter, faster, more enduring. In a world of shifting climates, these advantages matter. Climate, after all, defines the Triassic. Pangaea still dominates, stretching across most of Earth's surface. This vast supercontinent creates extremes: hot interiors, arid deserts, violent monsoons along coasts. Fossilized sand dunes in what is now the American Southwest show deserts rivaling the Sahara. Yet elsewhere, lush floodplains thrive. In such variety, evolution experiments. And in those experiments, dinosaurs find their stage. The first true dinosaurs appear around 230 million years ago. Eoraptor, small and agile, darts through South American forests. Herrerasaurus, one of the earliest large predators, stalks prey with serrated teeth. Coelophysis, slender and fast, hunts in packs across floodplains. Smithsonian researchers studying Argentina's Ishigualasto Formation call it a dinosaur cradle, preserving these earliest forms. At this stage, dinosaurs are not yet dominant. They share the land with synapsids, amphibians, and other reptiles. But they are rising. With each passing million years, they adapt, diversify, and spread. Their respiratory systems, more efficient than those of synapsids, give them endurance in low oxygen air. Their eggs, laid in nests, allow new strategies of reproduction. Their light skeletons, reinforced by strong muscles, balance speed and strength. The oceans mirror this experimentation. Ichthyosaurs, reptilian swimmers shaped like dolphins, appear, diving deep into Triassic seas. Nothosaurs, with paddle-like limbs, hunt fish along coasts. Early plesiosaurs stretch long necks above the waves. Marine reptiles take over the roles left by extinct fish and amphibians. For the first time, the seas belong not to fish, but to reptiles. And then there are the pterosaurs, the first vertebrates to truly conquer the air. With membranous wings stretched between elongated fingers, they glide above rivers and forests. Small at first, no larger than gulls, they already carry the spark of what will one day become giants with wingspans rivaling airplanes. The Triassic is a time of recovery, but also of innovation. Nature, scarred by the Permian, becomes restless, creative, daring. Every niche left empty is tested, filled, transformed. But recovery is never simple. Disasters still strike. Volcanic eruptions, smaller than the Siberian traps but still vast, send ash and gases into the air. Climate warms further, then swings abruptly. Oceans falter, oxygen dropping again in intervals. Extinction pulses ripple through life, cutting short some experiments. Smithsonian geologists trace chemical signatures in Triassic rocks that reveal repeated crises, and yet, unlike in the Permian, life weathers them. Perhaps because ecosystems are still sparse, more flexible, perhaps because survivors carry hard-earned resilience. Toward the end of the Triassic, another great upheaval comes. Around 201 million years ago, Pangaea begins to tear apart. Cracks split continents. Lava fountains along what is now the Atlantic in an event known as the Central Atlantic Magmatic Province. Carbon dioxide floods the skies once more. Temperatures surge, oceans warm and acidify. Many species fall, amphibians, large synapsids, several reptile groups, but not dinosaurs. Dinosaurs survive, and more than survive, they flourish. The very extinction that topples their rivals clears the way for their dominance. In the Jurassic that follows, dinosaurs will rise to global power, filling landscapes with forms astonishing in scale and diversity. But in the Triassic, they are still beginnings. Small, swift, adaptive. Watching, waiting, preparing to inherit the Earth. What does this world feel like? Imagine standing on a Triassic plain. The air is hot, thick with summer storms. Ferns brush your legs, and cycads stretch upward like palms. A river runs brown with monsoon rains, its banks crowded with amphibians. In the distance, Rauisuchians prowl, massive shadows with jaws that snap bone. But nearer in the brush, something smaller moves, light-footed, graceful. A pack of Calophysis, eyes bright, hunting together. They are not yet rulers, but they will be. The Natural History Museum in London notes, the Triassic is less about abundance than about resilience. It shows us how life rebuilds, not in a rush, but in a long patience. Each survivor carries the memory of loss, and in that memory, it adapts. The Permian ended in fire and poison. The Triassic begins in quiet and ends in tremor. Between them lies the slow rebirth of Earth. Forests return, oceans refill, skies welcome wings, and in this rebirth, the stage is set. The age of dinosaurs is about to begin. When the curtain rises again in the Jurassic, it will be with thunder. Giants will walk. Forests will echo with calls never heard before. Seas will teem with predators vast and sleek, but all of it rests upon this fragile beginning. The Triassic whispers a lesson. Recovery is possible, but it is never guaranteed. Life is stubborn, inventive, courageous. From the smallest cynodont scurrying in the ferns to the first dinosaur stepping lightly across the floodplain, each is part of a slow symphony of survival, and that symphony is what will carry us forward. The age of giants reaches its peak. It is the Cretaceous, the final chapter of the dinosaurs' reign. Forests cover much of the continents now separated from Pangaea. Lush, green, filled with flowering plants, the first true blossoms to ever decorate Earth. Bees and butterflies, co-evolving with these flowers, hum across fields. Insects discover nectar, and plants discover new ways to spread their pollen. Smithsonian paleobotanists often describe the Cretaceous as the flowering of the Earth, when the landscape finally begins to resemble the one we know. Dinosaurs thrive in this world. Some are titanic. Argentinosaurus, longer than a blue whale, thunders across South American plains. Others are armored, like Ankylosaurus, low to the ground, with tails tipped like hammers. Still others take to the skies. Pterosaurs now massive, some with wingspans as wide as small planes. And at the very peak of predatory design, Tyrannosaurus rex, jaws lined with teeth that could crush bone, eyes forward, hunting with relentless power. The seas, too, are alive with monsters. Mosasaurs glide through oceans like giant lizards turned into whales. Plesiosaurs with serpentine necks lift their heads above waves, stalking fish. Sharks circle in numbers, new forms evolving to match the changing seas. Life in the Cretaceous is abundant, varied, flourishing. It is a golden age, yet golden ages are fragile. Deep beneath the crust, Earth stirs restlessly. Volcanic activity spreads across India in what will become the Deccan Traps, releasing immense amounts of carbon dioxide. Climate warms, seasons grow harsher, but it is not this alone that will end the age of giants. The true catastrophe comes from beyond. 66 million years ago, a rock drifts through space, 6 miles wide, traveling faster than a bullet. It has wandered for millions of years, indifferent, silent, until gravity pulls it toward Earth. The Yucatan Peninsula in what is now Mexico becomes its target. When it strikes, the world changes in an instant. The impact is more powerful than billions of atomic bombs. Temperatures at ground zero rise above the surface of the sun. A crater 150 kilometers wide rips open the crust. Mountains of vaporized rock erupt skyward. Smithsonian scientists studying the Chicxulub crater describe the shockwave as one of the most violent moments in Earth's history. The first to die are those nearby. Forests incinerate, oceans boil at their edges. Within hours, tsunamis radiate outward, hundreds of meters high, sweeping across coastlines. But it is what comes after that seals the fate of the dinosaurs. The sky darkens. Dust, ash, and aerosols launched into the atmosphere encircle the globe. Sunlight fades. Days turn into twilight. Temperatures plummet. Photosynthesis falters. Plants wither. Plankton, the foundation of marine food webs, collapse. National Geographic notes that within weeks, global ecosystems begin unraveling. Starvation follows. Large dinosaurs needing vast amounts of food fall first. Tyrannosaurs, Triceratops, Hadrosaurs, giants that once dominated plains, find nothing to eat. Smaller creatures scavenge what they can, but the collapse is total. In the seas, mosasaurs and plesiosaurs vanish as food chains crumble, and yet not all is lost. In burrows and forests, in rivers and along coasts, small creatures endure. Birds, the only surviving dinosaurs, take flight into the darkened skies. Mammals, tiny and adaptable, feed on seeds, insects, and detritus. Crocodiles, able to survive long periods without food, retreat to rivers and wait. Turtles bury in mud. Life shrinks, but persists. This moment, the end of the Cretaceous, is known as the KPG extinction. Smithsonian records state that more than 75% of species vanish. It is, like the Permian before it, one of Earth's great erasures. But unlike the Permian, the cause is clear: an asteroid, the most famous killer in Earth's history. Imagine the silence after. For millions of years, Earth is quiet again. The thunder of sauropods gone, the roar of tyrannosaurs silenced. Only the whispers of survivors remain, and yet, from those whispers, a new story begins. Mammals, once hidden in shadows, emerge. Freed from dinosaur dominance, they diversify quickly. Some grow larger, exploring niches once filled by reptiles. Within 10 million years, primates appear. Within 66 million, humans will walk. The Smithsonian Natural History Museum often frames the asteroid as both an ending and a beginning. Without it, we would not be here. But let us not forget what was lost. The Cretaceous was not merely a prologue to us. It was its own world, filled with splendor. Herds of hadrosaurs migrating across floodplains. Armored ankylosaurs defending with tails like living weapons. Raptor packs hunting with cunning. Pterosaurs soaring above oceans at sunset. A golden world ended in an instant. Standing today at Chicxulub on the Yucatan coast, one can still feel it. The crater lies buried, but its rim stretches for miles. Drilling projects reveal shocked quartz, melted rock, and layers of iridium, a metal rare on Earth but common in asteroids. These are the fingerprints of catastrophe. They tell us, the story is real, it happened, and it changed everything. NASA scientists remind us, asteroids still cross Earth's orbit. Chicxulub was not unique, it was simply the one that struck. The lesson it leaves is sobering. Life on Earth is resilient, but also fragile. Worlds can turn in a single day, and so the Cretaceous ends. When we close our eyes and listen, perhaps we can still hear echoes. The low rumble of a sauropod moving through trees, the splash of a mosasaur breaking the surface, the rush of wings from a pterosaur in flight, sounds forever silenced, yet still alive in stone and fossil. And in those fossils, stories. Stories that remind us of grandeur and loss, of chance and survival. Stories that lead from the shadow of the asteroid to us sitting here, remembering the age of dinosaurs lasted for more than 160 million years. But in the end, it ended not with a slow decline, but with fire from the sky. And because of that fire, another story could begin. The story of mammals. The story of us. The story of extinction has always felt like something distant, something ancient. Ordovician seas, Devonian reefs, Permian deserts, Triassic storms, Cretaceous skies, each collapse unfolding over millions of years, each disaster buried in stone. But tonight, we are not traveling back. Tonight, we are traveling here, now into the age we live in. Into the Anthropocene, into the sixth great extinction. The word Anthropocene means the age of humans, not officially yet, but increasingly recognized. Geologists at the International Commission on Stratigraphy still debate where exactly to draw the boundary. Some say it began with the Industrial Revolution, others with the detonation of the first atomic bomb. Others still with the rise of agriculture thousands of years ago. But all agree, this epoch is shaped not by tectonic plates, not by asteroids, not by volcanoes, but by us. For the first time in Earth's story, one species holds the power to alter the fate of all the others. Smithsonian curators call this a planetary-scale experiment with no precedent. We are both actors and authors of the script, and the stage is global. The signs are everywhere. The World Wildlife Fund's Living Planet report states that since 1970, wild vertebrate populations, fish, birds, mammals, amphibians, reptiles, have declined by an average of 69%. Almost 7 out of every 10 wild animals gone in just 50 years. For a planet 4.5 billion years old, 50 years is less than a blink. It is the flicker of a second. Forests vanish. The Amazon, once a nearly infinite green, now loses thousands of square kilometers each year. Chainsaws carve openings where jaguars once hunted. Birds vanish from canopies that no longer exist. The lungs of the earth gasp. In Borneo, orangutans cling to shrinking trees, their habitats replaced by oil palm plantations. In Africa, elephants walk ancient routes only to find fences, farms, highways. In oceans, coral reefs bleach white, skeletons of colorless stone where once fish shimmered in clouds. Climate change adds another layer. Human industry has raised carbon dioxide to levels not seen in millions of years. NASA records show atmospheric CO2 now above 420 parts per million, higher than at any point since the Pliocene. The seas warm, ice melts, oceans grow acidic. Storms strengthen, droughts stretch longer, fires consume forests. For countless species, the pace is simply too fast. Evolution cannot keep up with combustion engines and factory smokestacks. Elizabeth Colbert, in her Pulitzer-winning book The Sixth Extinction, writes, "The most distinctive feature of the present is not that humans are altering the Earth's systems, but the speed at which we are doing so." She notes how amphibians, the most ancient survivors, are now among the most endangered. Frogs disappearing from mountain streams, their calls silenced by chytrid fungus spread through global trade. Birds collide with glass towers, whales choke on plastic. Insects, the quiet engineers of ecosystems, decline in staggering numbers. German entomological studies reveal insect biomass falling by more than 70% in a few decades. Without insects, pollination falters, soils weaken, food chains collapse. What does it mean to live inside an extinction? Past extinctions were invisible to those who lived them. Trilobites did not know the seas were ending. Dinosaurs did not see the asteroid in the sky, but we, humans, know. We measure it, we debate it, we hold conferences about it, we publish graphs, reports, warnings. The Intergovernmental Science Policy Platform on Biodiversity and Ecosystem Services, an arm of the United Nations, estimates that 1 million species face extinction within decades. 1 million. Imagine the sound of 1 million voices silenced, songs we will never hear, patterns never traced, eyes never meeting ours. And yet, even as the data grows darker, the story is not only one of loss. There is also resilience. There are pockets of survival. Whales, once hunted nearly to disappearance, now slowly recover under international protections. Bald eagles in North America, once rare from pesticides, soar again after the banning of DDT. Wolves return to Yellowstone, reshaping rivers and forests. Sea turtles hatch on beaches once thought lost. The story is not written in only one direction. Still, the tension remains. We are both destroyers and stewards. Our tools cut forests, but also replant them. Our nets empty seas, but also monitor them. Our industries heat the planet, but our science warns us how to cool it. We are the first extinction driver aware of our role. That awareness is both burden and possibility. Consider coral reefs. Scientists predict that by mid-century, 90% could be gone if warming continues. Yet experiments show corals adapting in pockets, finding ways to survive hotter seas. Conservationists plant corals, like gardeners replanting meadows, hoping fragments grow into living reefs again. It is a race, biology against time. Consider birds. Billions die each year from glass collisions. Yet architects now design windows etched with ultraviolet patterns visible to birds but invisible to us. A small change in glass, a large change in survival. Consider forests. The Amazon may be nearing a tipping point, where deforestation pushes it from rainforest into savanna. But indigenous communities across the basin defend it daily, holding millennia of knowledge about balance, regeneration, and respect. Their fight is not just for trees, it is for a planetary climate. We live in the Anthropocene, where every action echoes globally. Eating a hamburger links to forests cleared for cattle. Buying a phone links to mines that cut into gorilla habitats. Driving a car links to glaciers melting far away. For the first time in history, the ordinary is planetary. And so we stand at a crossroads. Past extinctions were beyond control. Ice ages could not be voted against. Asteroids could not be negotiated. But this extinction is different. This one is in our hands. The Natural History Museum in London states the current rate of extinction is tens to hundreds of times higher than the average across the last 10 million years. But unlike before, the driver is conscious, which means the outcome is not fixed. We may yet choose differently. Picture a future 200 years from now. One story says the forests are gone, the seas empty, the air heavy with heat. Humanity survives, but in a narrower, lonelier world. Another story says forests return, seas heal, new balance emerges, richer and more stable. Which story unfolds depends on choices being made, even now. Extinction is not only about biology, it is also about imagination. Can we imagine a world where technology and ecology are not at war? Can we see ourselves not as separate from nature, but as part of it? The poet Robinson Jeffers once wrote, "Integrity is wholeness. The greatest beauty is organic wholeness, the wholeness of life and things." The Anthropocene challenges us to rediscover that wholeness before it unravels. Perhaps this is the paradox. The Anthropocene is both tragedy and opportunity. Tragedy because species are vanishing faster than at almost any time in Earth's story. Opportunity because, unlike before, the agent of extinction can also be the agent of restoration. The silence of vanished voices grows each day. But alongside it, so does a chorus of human voices calling for change. Scientists, activists, artists, farmers, engineers, each speaking of renewal, of care, of survival. Elizabeth Colbert warns us of what is lost, but she also reminds us, extinction is not destiny. It is a path, and paths can be changed. So we stand, looking forward. The sixth extinction is here, but it is not complete. The curtain has not yet fallen. The lights have not yet gone out. There is still time, though not much. The fossils of the future are being written now, in forests logged or preserved, in rivers dammed or left to flow, in skies choked or cleared. We are living inside the story that future museums will tell. What will they say? That humanity knew but did nothing, or that humanity knew and chose differently? The answer rests not in stone, not in stars, but in us. The Ordovician ended in silence of oceans, the Devonian in silence of reefs, the Permian in silence of deserts, the Cretaceous in silence of skies. The Anthropocene asks, will we end in silence too, or will we find another voice? The sixth extinction is not only about the loss of others, it is also about the discovery of ourselves, about what kind of species we wish to be, about whether we will see life as expendable or as sacred, about whether we will close the theatre of the earth or keep the play alive. The choice is not abstract, it is daily, material, present. It is forests standing or falling, rivers running or drying, species surviving or vanishing. It is, in the end, us. And so, as night deepens, we return to where we began, to a planet that has endured 5 extinctions already. Each time, life rebuilt. Each time, new forms arose. But never before has one species had to decide whether to prevent an extinction or to allow it. That is the singular weight of the Anthropocene. That is our inheritance. We are the asteroid now, but we may also be the seed. The 6th extinction is underway, but its ending, unlike all the others, remains unwritten. When you step back and look at the grand arc of time, something curious emerges. Extinctions are not random. They leave behind patterns, coincidences that seem almost scripted, as if life itself breathes in rhythms too vast for us to fully hear. Each of the 5 great extinctions came at moments when Earth systems tilted out of balance, shifts in oceans, in skies, in fire, in ice, different causes, different scales, but the same result, ecosystems unraveling. The Ordovician ended with freezing seas, the Devonian with collapsing reefs, the Permian with poisoned air, the Triassic with volcanism and carbon, the Cretaceous with a falling stone. Different triggers, but similar echoes. Life flourishing, then faltering. Abundance, then silence. Paleontologists often note that these events seem to cluster in strange rhythms, not exact cycles, not clockwork, but patterns. Some researchers propose a pulse to extinction, tied perhaps to tectonics, perhaps to cosmic movements, perhaps simply to the fragile balances within ecosystems themselves. The truth is uncertain, but the repetition is undeniable. Catastrophe followed by renewal, collapse followed by creation. Coincidence also lives in the survivors. Across each extinction, certain lineages endure. In the Ordovician, small brachiopods clung to existence. In the Devonian, the ancestors of amphibians crept onto land. In the Permian, tiny mammals-to-be survived where giants fell. After the Cretaceous, small birds outlasted their towering dinosaur cousins. Survival, it seems, favors the adaptable, the quick to hide, the quick to change, the quick to endure scarcity, a pattern as old as life itself. And there is another coincidence. Each extinction opened a door, cleared a stage. The fall of trilobites made room for fish. The collapse of giant amphibians made way for reptiles. The vanishing of dinosaurs gave mammals their chance. Out of silence, new voices always rose. Out of endings, beginnings. This, too, is a rhythm of Earth. What does that mean for the Anthropocene? If history holds, then the silence we create will also one day be filled. Forests may vanish, but other forms may rise. Species may fall, but others may adapt. The pattern is larger than us. The coincidence is that every extinction paves a path for renewal, but for the first time, we are present to witness it. For the first time, the pattern is visible while it unfolds. This awareness changes everything. Dinosaurs never knew they were fading. Ammonites never knew their shells would be the last. But we, humans, see the graphs, the statistics, the losses. We know the pattern is repeating, and because we know, we are forced to ask, will we be among the survivors or among the vanished? Coincidence also whispers in smaller ways. The asteroid that ended the dinosaurs struck at precisely the right angle, precisely the right speed, precisely the right time. Had it been slower, faster, or missed entirely, the world today would look nothing like it does. We would not be here, speaking, listening, reflecting. Our very existence is a coincidence born of extinction. It is a humbling thought. Without disaster, there would be no us. Without silence, there would be no song. Without endings, no beginnings. The fossils remind us of this. The patterns insist upon it. And so, as the story closes, the question lingers. If extinctions are inevitable, if coincidences shape survival, then what is our role? Do we fight against the pattern, or do we soften its edges? Do we allow it to sweep us away, or do we learn to bend with it, to live within its rhythm instead of against it? Perhaps the real coincidence is that the species capable of ending so much life is also the species capable of choosing differently. The pattern says collapse follows abundance, but maybe, just maybe, awareness can bend the pattern. Maybe for the first time the cycle can change, because patterns are not prophecies, they are reminders. They whisper of fragility, of resilience, of connection, and they ask us to listen, to notice, to imagine ourselves not as masters but as participants, not as separate but as woven in. Coincidence brought us here. Patterns guide us forward. The rest remains unwritten. We began this journey by stepping out of our own time into the deep memory of Earth. We walked through oceans that no longer exist, forests that turned to stone, skies that once carried different air. We watched entire worlds rise and vanish, and in their silence we found the echoes that reach us still. Extinctions feel like endings, but across 2 hours what becomes clear is that they are also beginnings. The Ordovician stripped the seas, and in time reefs returned in new forms. The Devonian silenced fish, and new lineages took their place. The Permian nearly ended complex life, yet from its ashes came dinosaurs and mammals. The Cretaceous asteroid ended the reign of giants, and from its shadow, small creatures like us inherited the Earth. Even now, as we shape the Anthropocene, patterns repeat. Loss and renewal, silence and song. And this is the truth hidden in deep time. Life is not fragile in the way we imagine. Individual species are fragile. Ecosystems are fragile. But life itself is persistent, inventive, stubborn. It always finds the cracks, the hidden corners, the small shelters where it can endure. It waits, it adapts, it begins again. For us, the perspective is both terrifying and comforting. Terrifying because the Earth does not need us. We are not essential to its story. Our cities, our languages, our achievements, on the scale of geology, they are moments, sparks, already fading. And comforting because it means the story of life is larger than our mistakes, larger than our fears. Even if we falter, the Earth will continue. Even if we vanish, the song will not end. It will change, but it will not stop. Yet we are not powerless. Awareness is our gift. Unlike the trilobite crawling across empty stone, unlike the ammonite floating in poisoned seas, unlike the dinosaur watching fire fall from the sky, we know. We see the pattern while it is still unfolding, and that knowledge carries weight. Perhaps this is what makes our time unique. Not the scale of extinction, but the presence of witnesses who can also act. We can choose how sharp the silence will be. We can choose how much abundance remains. We can choose whether the survivors inherit a world of possibility, or only the narrowest corners to cling to. It is easy to feel small in the face of such vastness. To imagine that our choices are dust against the weight of tectonics, oceans, or asteroids. But every extinction began small. A drop in temperature, a rise in carbon, a shift in current. Tiny changes cascading outward until the world remade itself. If small causes can collapse abundance, then small choices can also protect it. This is the paradox we inherit. We are insignificant and we matter immensely. The Earth will endure without us, and yet, while we are here, we shape what endures with us. So what do we leave behind? Fossils will one day remember us, but not in detail. The record of bones and shells is too faint. What matters more is what lives after us. The forests, the reefs, the birds, the whales, the voices we allow to continue their songs. The closing reflection, then, is not a warning nor a prophecy. It is an invitation to see ourselves not as rulers of Earth, nor as its final word, but as its temporary guests. Guests who can choose to honor the house they inhabit. Guests who can leave the stage ready for the next actors instead of scorched and broken, because extinction is certain, but so is renewal. The pattern cannot be erased, but it can be softened, it can be shaped, and in that shaping lies meaning. So tonight, as we close the curtain on deep time, remember this: endings are never just endings, they are thresholds, they are doors. And beyond every silence, a new voice waits to be heard.